Okay, welcome back. So now let's take a look at an algorithm for clustering called k-means clustering. So what's the idea here? Suppose you're given points. So here we are looking at two-dimensional points in 2D space. And that means each point has two coordinates. And if you look at visually, if you plot them and you can look at them visually, you can see clearly two groups. But the problem is, how do we figure this out, what these two groups are? Also keep in mind that the points we are dealing with can be high dimensional, so we cannot even plot them. So the idea would be that we will be able to find some mean, which means the middle point and all the points that are closest to that point, as well as another middle point that are closest to that point. So in this case, we will assume that we're going to find two clusters, so k equals 2, and then we're going to find all the points that are closest to that cluster. In other words, the label for all these points, the blue points, is going to be the mean, and the label for all the orange points is going to be this label here. Now you can decide to do more clusters. Now clearly this one has the number of clusters finalized. So let's take a look at a particular example. So suppose we have 4 points in the space, in the two-dimensional space. If you actually plot these things, you're going to see the clusters very clearly with which ones are closer to each other. But we're going to do this using an algorithm called k-means algorithm. So we're not going to give you I'm going to show you the demonstration of the algorithm. So basically what we're going to do is we're going to pick two random points as the centers. These random points come from the cluster itself, all the points, the initial points. So initially, the points, the cluster centers are one of these points. All right, so we're going to look for two clusters here. And as we go, those things will change, and the cluster means are no longer the points itself. So how do we compute the distance between 2 points? So for example, if you take this distance, this point, and this point here, which is 1, 1, and 0, 1, we like to find the distance between these 2 points. For that, we're going to use something called Manhattan distance. So what is Manhattan distance? So if you think about 2 points in Manhattan, you want to go from point A to point B, then you will have to go in the x direction, delta x, which is the difference of x coordinates, and delta y, the difference of y coordinates. So that's what we do here. So we take 1 minus 0, that's the difference of x coordinates, so that's 1. And then 1 minus 1 would be 0, and then the total is going to be 1. Now similarly, if you take this point and 1, 1, we take minus 1, that's minus 2, but we take the absolute value, which is 2, and then 0 minus 1 is minus 1, take the absolute value, which is 1, so we get the total of 3. So you get the idea. We do the distance by subtracting x coordinates, subtracting y coordinates, and taking the absolute value. So we fill out this table for all the points, the 2 points we selected, and for all the points here. And then what we're going to try to figure out is, like, given cluster 1, who is the closest to here? So for example, if you look at any column, the smallest number, like here, if you look at these two numbers here, the smallest number is the closest. So we say that this point is closest to that point, which is kind of trivial because it's the same point. Now the same thing is here. We look at this point, we look at this column, and we say 2. So this means this point, P2, is closest to 0, 1. And then if you look at this column, 1 is the smallest of the two. And then we say P3 is closest to this. And same way, P4 is closest to the second point, and so on. So we have put some identification to indicate the clusters. So here we have, for the cluster 1, we have these 2 points, P3 and P5. And for the cluster 2, we have P1, P2, P4, right? So we have those things. And if you look at the total loss is how we control the convergence process. So we look at how much we gave up on here. So like the sum of these losses. So the loss is like the minimum value here. It's kind of like, we're not going to talk more about those things in a machine learning sense. But think about that. That is the price you paid to approximate. So it's a total loss 5. Okay. Now what we need to do is we take these two clusters and compute their mean point. For example, the cluster mean P3, P5, the mean point is 1.51. How do we get that? So we look at cluster point P3 and cluster point P5. We add the x coordinates, 2 plus 1, which is 3, divide by 2, give you 1.5. Then we take 1 plus 1 divided by 2 gives you 1. And this one you have to add the 3 points of the x coordinates and 3 points of the y coordinates and divide by 3. So that's what we do here. So we take these 3 points, add the x coordinates. So for example, we have 0 plus minus 1 plus minus 1. So that's minus 2. All right, so minus 2 divided by the 3 points. So you get minus 2 over 3. And the same thing with the y coordinates for this one. 1 plus 0 plus 2, which is 3 over 2, 3 over 3, which gives you 1. So those are the new cluster centers. So we got the new cluster centers here. All right, and then we'll do the same thing we did before. Like we will compute the distance between this point and that point. So we will figure out what those numbers are. The same process as before. Now we get a smaller number here, 0.44. This means that P1 belongs to this cluster, represented by this new mean, and P2 belongs to that because that's the smaller of the two here, and the smaller of the two here is 0.25, 1.1, 0.25. So we get, but the clusters did not change, although the total loss went down. So when the clusters don't change, this means that when you take the next mean, it would be the same table because you have the same clusters. So ideally clusters should change as we go. This is a small example, so that's why we don't see a lot of changes here. But in this case, the loss went down, but the clusters didn't change. So we're going to stop here. So what is the criteria for stopping? If the total loss starts to diverge for some reason, or clusters do not change, we can stop the process. Because as clusters do not change, the mean is not going to change. Therefore, everything is going to be just repeating the same thing. So in this case, we determine that the final clusters are P3, P5, and P1, P2, P4. All right. So that's the K-means algorithm. Now, one of the things you will notice is that as you iterate through this algorithm, the loss will begin to decrease. And we saw that in the previous case. We went from 5 to 3.17. Okay, so loss is going to decrease. And then we're going to see that. And when to stop, maybe when the loss is not decreasing so much, we can stop because we don't have to do more computation. Or you stop when the clusters don't change. Now, typically, in a very large set, the clusters will always change. You will move from one to the other. But at some point, you have to stop iterating. So that's the idea of the K-means clustering. Now here's another example of a data set that clearly has 3 clusters, but we got to find the cluster means. So the way we start is that we randomly pick 3 points from the data set, and then we start to iterate. So you will notice that when the next iteration, this middle point has moved down, and you will notice that that's kind of coming down here. And this middle point error now, this is the mean that represents this group. And then it keeps moving. It keeps moving to the middle of the thing, and then eventually you stop. Seems stable. This means that the loss is not changing as much anymore. But so you have identified 3 cluster centers that will work with. So now the K-means algorithm, we don't expect you to know. Well, you know it. You actually did it. But this is what the algorithm is if you're going to implement it by itself. So the K-means objective is non-convex. That means we'll not talk about those things. That's beyond the scope of this course. But basic idea is that you choose a random set of K-means from M points. You have M points, and you choose K-means. That means we want to, like, for example, if you think about the grades, I want to have 5 groups of grades, A, B, C, D, F, right? And the cluster points can have dimension in each of those things. And then the idea is you compute the cluster center as the mean, all points assigned to that specific mean. So we have a data set of m things, we choose k clusters, we randomly pick k of those points to be the cluster mean, and then we compute the cluster assignment. So there's some math here that, let's not worry too much about that, as long as you understand the process going on, right? So in the next case, we will just talk about the applications of that.